of modeling, that is solid modeling, surface modeling, okay, and the parameter related to that modeling, right? Wing parameter and fuselage parameter. Okay, so these all things we have covered. Okay, so today I'll be just revising completely about the topics which has been covered so far in this 1 week. Okay, so here the open VSP, it's our open source software, right? So here open VSP will give you the chance to do openly your any kind of projects or models, especially related to the aircraft, right? So in our first class, we have seen that introduction part about the open VSP, right? That is our open VSP is a vehicle sketchpad, or VSP stands for vehicle sketchpad. Open in the sense it's open source software. That's why we are calling this software as a open VSP software, or open vehicle sketchpad software is an open source parametric aircraft geometry tool originally developed by NASA. Okay, so this is how it looks. Different types of models when you'll be designing, and simultaneously you can go for analysis. This part also covered. Okay, and who discovered or who invented this software. About those people also we have discussed. That is GR, Glaudemans, and other who are working in NASA. So they have worked, and also Rob McDonald and other people. These things also discussed, and OpenVSP versions like which has been released initially. There is OpenVSP V 2.0 released, and after that, now we have different type of versions, right? So, like if you know this website, then just you have to open this website, or just you copy this website like this same, okay, and you go to the Google and paste here. Okay. So as soon as you paste, you will open that website. Okay, which means you'll reach to the OpenVSP website. Okay. From this, you can download the software. Just click on the software. I mean, like click on that download option and get started with your OpenVSP. Okay, so here we have so many versions under this download. As soon as you click on the download, you can able to see the Windows version, Mac OS version, okay, and other versions we have. Okay, so just I'll prefer all of you just go to full download, and for Windows, whichever required for your case, this that version you can download. Okay, and for my point of view, my laptop will follow 3.17.0. So not only my laptop, maximum Windows 8, Windows 7, Windows 8, 10. So if you download the OpenVSP 3.17.0, then you can able to access in those Windows. Okay, so that's why you just download this OpenVSP 3.17.0. So just click on this. As soon as you click on this OpenVSP 3.17.0 version software, then you can able to see the download notification, which means your software is getting downloaded. Okay, and it's here we can see, we can able to see it's downloading. Okay, so as soon as it's download, just open that software. Okay, that software whatever we have, it is in zip format. Okay, so this zip software we have to convert in terms of this folder. Okay, so for that what we have to do, just we have to right click on that zip folder and go to open with, and click on the second option, Windows Explorer. Okay, and copy this, paste here. size of this software 27.1 MB. Okay. Yes. Now open this folder and continue with your software. Just double click on this last fourth option and run that. Yes. See, this is your software which is ready to work. Okay. So I'll discard this because I already have opened my old downloaded Open VSP 3.17.0 software. Okay. So here, after downloading, we know that we got this two window, right? This window and this one window, right? So as soon as we download and we have clicked on this VSP.exe file. Okay, so after clicking on this, you can able to see we have reached to the windows, two windows of our Open VSP. These two window what we have, for this window we will call one window as our VSP window and other window we have the geometry browser window. Okay, this one. In this VSP window, you can able to fix your model or you can add your model by using the geometrical browser window. In this geometrical browser window you have all the models. These are all models what we have. It's a inbuilt model, that is our fuselage, wing, stack, blank, ellipsoidal, body revolution, propeller, hinge, okay, box, and all other components we can able to see. These all components we need for our aircraft design, right? So these are all components whatever we have. Okay, so these are all components, they are inbuilt components. Okay, so here for this inbuilt component, as soon as you select and you add, then we can able to see we got some default wing, right? For this default wing you can add your parameters. Okay, so these things also we have discussed. So what I'll do, I'll delete this wing. Okay, so like this we can operate with our VSP window and our geometry window. Okay, so in this VSP window we have files, edit, file menu, edit menu, window menu, view, model, analysis. Okay, by using files you can able to open your file, you can save as. Okay, you can insert. Okay, if you want to insert any other file you can insert. Okay, or if you want to import any file you can import some X file in this OpenVSP, or else you can export your file. Okay, in this all format we have all this format. In all this format you can export your .vsp file. Okay, and if you have any script then you can run your script. And finally, if you don't want to work with this window or with the software, then just click on exit and discard. Okay, as soon as you click, then you can able to see the complete software got shut down. Okay, so just to open once again, what we have to do, we have to go to our open VSP folder which you have downloaded. Okay, so open that and just double click on your last fourth option. Okay, so here we have edit second menu, that is our edit menu. By using this edit menu you can cut, copy, paste, delete, or you can select your all components. Okay, and we have toggle mode. Okay, now suppose I will add one component. Okay, in this in this case you can cut and again you can paste, or you can copy or you can paste. Okay, or you can directly delete that complete model. Just select and delete. If you have one or two components like this, okay, if you have any randomly come some unknown and known components, okay, and simultaneously you want to select all those components, then just go to edit and last second option you have to click to select all the components. Okay, and we have window option. Okay, suppose you have designed any model like this. Let me open one model which I have so that it will be clear to you. Just 2 minutes, I will connect. Yeah, okay, wait. Wait. Yes. So we have one model. Okay. Yes. Now see, we have this option, right? Window option. Okay. So by using this window option, you can increase your number of windows, open VSP vehicle sketch page windows by using this window option. Okay. Now currently we have only one VSP window. Okay. Simultaneously, you can increase your window from 1 to 4 like this, and you can work on each and every window respectively by clicking on that particular windows. Okay, like this. And similarly we have two horizontal window, two vertical window, and if you want to take any screenshot, you can take screenshot, and you can increase your width and height and ratio. You can save your image, access toggle and all. Okay, if you want to off this access toggle, you can off. If you want to use that access toggle, you can use. Okay, and border toggle in this red background, what we have, this one, this red background. Okay, that if you want, you can on that checkbox. If you don't want, then just off the checkbox. Okay, next we have the view option. By using this view option, you can view your model with respect to the given views, that is the front view, left view, iso view, bottom, rear, like this. Okay, you can change your views, or else you can directly use F5, F6, F7, F8, F9 buttons. Okay, I mean like keyboard, then you can able to see the respective views. Okay, and in this model, okay, we have geometry, type editor, set editor, link. Okay, these are things I will discuss when we will go for a particular model designing, that is when we design our respective models, wing model or fuselage model, that time we will use all these options. And similarly, after designing model, we have to do analysis. No, that time I will explain about this, as I told, as I discussed in my previous classes also. Okay, So yeah, so after introduction and all, okay, after a minute chart and all, yes, we have even discussed about the three stages of an aircraft design. Okay, that is our, as soon as you get requirement from the customer, so you'll be working for the customer's requirement. Okay, so initially directly you will not go for any kind of aircraft design. First of all, you'll analyze the requirement, right? Directly you will not go for any kind of aircraft design. So demand, whatever demand you will get from the customer, so based on the demand or based on the customer's requirement, we will follow some procedure, design procedure. That procedure we even have discussed, that is the conceptual design, preliminary design, detailed design. After that we'll go for fabrications, right? So as an aircraft designer, demanding requirements to produce an aircraft that is strong, lightweight, and economic factor. Okay, and other factors we have to keep in our mind. Based on those factors, we have to design any kind of aircraft, whether we are designing small aircraft like Cessna or your rotorcrafts, okay, or fighter crafts, small fighter crafts, okay, or any large aircraft like a Boeing, Airbus, or Airbus A380, Airbus A330, or Boeing 777, or Boeing 737, like that. If you're designing any aircraft, so we have to go with this all process, okay. So in this first process, we have the conceptual design. So this is the first stage of an aircraft. This is very beginning stage, as we can see. In this case, we will be just doing the conceptual parts of an aircraft. Okay, roughly we'll design and roughly we'll analyze the required parameters for designing point of views. Okay, so every aircraft designer, they have to ensure and they have to work to achieve a design that has to meet with the requirement and all. Okay, and we even go for the preliminary stages after completing of our conceptual design part. Okay, so which means this open VSP what we have, by using this open VSP, we can complete our first stage of our aircraft design. That is the conceptual part. That is also I have shown and I have told that. Okay, yes, so like this you can complete your model, and you can even do your complete structure, aircraft structure or design point. Okay, and afterwards even we have discussed about the solid modeling process. Okay, so solid modeling, 3D modeling allows engineers to flush or to get their idea about the complete scenario about the 3D model. Okay, so here, as an aircraft design engineer or as an any designing person, your main aim what you have to keep, that whatever design will be achieving at the end, okay, that design, how it may look initially, that analysis you have to do, no, before just directly going for fabrications and all. That analysis can be done by using the softwares, right? We have cadia and analysis softwares. Like that only we have our ANSI software, where we can do easily the conceptual step of an aircraft design. Okay, that conceptual steps can be completed by using the open VSP. And this open VSP, what we have, it's just whatever you'll waste your time for designing, especially by using the tools called as CATIA, or to complete your analysis part by using the ANSYS or any kind of 3D softwares, okay, which are high fidelity softwares. So there we will waste our time to design this kind of complicated structure. So instead of wasting time and to save our time, we have our conceptual designing tool, that is the open VSP. By using this open VSP, we can able to convert our required parameters into a complete model. Okay, so by using this model, you can even do analysis part. Okay, whether you want to go for VSP, aero analysis, or wave drag, or parasitic drag, or CFD mesh. So like this, all analysis part also can be done by using the open VSP. These things also discussed. Okay, So afterwards, we have jumped to the parametric modeling involved, right? So in this parametric modeling, we have seen the different types of parameters for our wing. Okay, so during the wing design we have these parameters. There is a wing reference area, number of wings, vertical positions related to fuselage, horizontal position related to the fuselage, cross sections, aspect ratio, taper ratio, tip chord, root chord, mean aerodynamic chord, span, twist angle, sweep angle, etc. Like this we have different parameters, right? So these all parameters we have to calculate, and geometrical part has to be completed neatly, especially for the wing. So based on this, we can import our values in the open VSP. Okay, here I'll delete this model completely. I'll discard, and I will once again I'll open the open VSP software. Yes, yeah. Okay, so I see here we have wing. As soon as I add the wing, so we can able to see we have the parameters, right? Span and a projected span, chord, area, aspect ratio, tip cap type, whether you want rounded, edge, flap, edge sharp or flat, even the root cap type. Okay, yes, which means these all parameters what we have with respect to our wing. These all parameters are very important for designing the wing. Okay, and even we have discussed at effect of aspect ratio on lift coefficient versus the angle of attack. Okay, here aspect ratio for aerofoil and for our 3D wing. As soon as you increase the aspect ratio of an wing, okay, then we can able to see for 2D case and also for 3D case, there's an increase in aspect ratio. Okay, as soon as you increase your wings aspect ratio, then your lift coefficient also will increase. These parameters, that is the aerodynamic center of wing, tip chord, root chord, and which type of wing we want to design, whether you want to design your rectangular wing or tapered wing or triangular or delta type of wing. So we have these three wings with a different taper ratio. And this is our top view of a wing with two sweep angle, first sweep angle and the second sweep angle. Okay, if you want to design such kind of wing, then you can design by using the open usp. Here we have section. Okay, so in this section you can cut the section into two parts by using this option split. Okay, so here we have two sections, first section and the second section. Okay, in this first section you can increase your sweep, and similarly you can jump to second section and you can increase the sweep angle like this, or you can decrease the sweep angle. And also we have different five wing with different sweep angle, wetted area, weighted aspect ratio for different aircraft, and the maximum L by D ratio for different aircraft, which is having different weighted aspect ratio. So here we have two wings, that is one is low aspect ratio wing and one more high aspect ratio. So here, if you increase the wing loading, then you have to increase the runway length, right? Because wing loading, in the sense, if you increase the wing loading, of course, you are increasing the W by S, right? Where we have that equation, say, aircraft by wing area. So this also has been discussed, and aspect ratio for different aircraft. Okay, and we have different aspect ratio for different geometrical wing section. Okay, this one we have the rectangular, compound, trapezoid, triangle. Okay, which means this type of wing, if you want to design, then you have to do the geometrical part correctly, and after completing the geometrical part, use those parameters in this open VSP and generate your required model. Okay, that's it. Now we have next, that is the different type of wings. At this part also I have discussed that if you want to design tapered wing with leading edge and straight leading edge, that also can be done. Or if you want to design the tapered leading edge and trailing edge, or you want to design delta wing. Okay, which means we have different wings, different type of wings. Okay, these all different types of wing can be designed by using open VSP software. Okay, that is what this diagram, it shows that initial rough sketch, that is the conceptual design step, right? That is what we are doing by using our open VSP software. Okay, the conceptual design, rough model, not a real model, rough model. Okay, for that rough model we are just analyzing that how the model will look after the design, and a similar model we can use as a reference for our design point of view, right? The only thing is that just we have to increase the scale size, and according to the scientific way, we have to move for the real fabrication part and all, right? This graph, it shows that if you are designing your aircraft which will go greater than Mach 1, then in that case we have to select the respective aerofoil. That is the thickness to chord ratio of that aerofoil should be in this range for Mach less than 1. Okay, so if you are designing any aircraft, okay, which will give a velocity in this range, that is the Mach number less than 1, then we have to select this kind of aerofoil having a thickness to chord ratio 0.12 or 0.11. If you're designing greater than Mach 1, okay, then you have to select the aerofoil which will be in this range. Okay, see, for greater Mach we have the aerofoils, or we can select the thickness to chord ratio of that ranged Mach number, right? So we have two Mach number. Okay, so for this Mach 2, okay, which means if you are designing aircraft, okay, which has to run with a velocity of Mach 2 or with a Mach 2, then for that case you have to select the aerofoil having a thickness to chord ratio 0.05. Okay, and after wing, even we have discussed about the fuselage parameters. Okay, so like this we have different fuselage okay, like rounded, slab sides, oval, rectangular to barrel box. So to design the fuselage, we have to calculate the parameters or geometrical parameters, the design parameters. That is the identifications of the fuselage design requirement, determine the number of crew members, how many number of crew members has to be seated inside the fuselage, okay, and determine the number of flight attendants, okay, for passenger aircraft we have to do that parameter also, determine the number of technical persons, establish the human size and target passenger, okay, because that fuselage whatever you will be designing in that fuselage number of people and with respect to the number of people when you have to adjust the seating capacity for those people also, right, whether you are designing for 10 people or whether you are designing for 100 people or 150 people, which means if you are going for passenger kind of aircraft design, then you have to increase your number of seats, right, whether you are designing aircraft just for rescue operations and all, then just 10 seat or 5 seats aircraft is enough, right, especially you are going for aircraft related to the rotorcraft or related to the plane, okay, or related to the fighter crafts. So like that, based on your customer's requirement, you have to design your fuselage, okay, and to design the fuselage we have all these parameters. These all parameters has to be done correctly. So once you're done with these parameters, then just import these parameters in the OpenVSP and you can able to generate the required fuselage. So we have the cockpit section, landing gear, passage, cabin system, cargo, fuel tank. So these all compartments has to be calculated properly because there's all compartments, whatever we have the cockpit system, cargo, fuel tank and all, it has to not disturb to the other compartment, right? So that disturbance will go away once you do correct calculations, the geometrical calculations. Okay, so that you can do correctly once you know the parameters, right? So that's why it's very important to analyze the geometrical parameters correctly for design point of view. Okay, these are passengers cabin requirements. Okay, and overall your cabin width and cabin length. Okay, nose section, philosophy width, stretches. Okay, so like this, even we have discussed about the different parameters what we need for fuselage design point of view, and also for wing design we have different parameters. Okay, so once you know all those parameters, then even we have discussed that and we have seen how to model our required parameter, right? I mean like required design as per our parameter what we have. Okay, our parameters like your fuselage length, width, seat capacities, seating arrangements, wing wing parameters, okay, number of wings, whether you want one wing or two wing, okay, or only you want to design main wing, okay, and other uh, parts like your engine and all. So to design any components whatever we have, okay, based on this component you have to calculate those parameters. Now I will add the wing. As soon as I add wing, we can able to see we have two components. Sorry, two. Uh, yeah, this fuselage wing geometry component, and one more we have the fuselage. Right. So here these alterations can be done for the respective components. Okay. Just wait. Let me delete this complete. Yeah. Okay. Yeah, I will add now. So see, in this case, when we have seen that we have the model, the wing model, whatever we have this wing model, we have called this as our wireframe model. Okay, so for this wireframe model you can hide that wireframe, the inner wireframe whatever we have okay, this aerofoils and all inner wireframes that can be hidden by using this hidden option. Okay, that also we have seen. And even you can shade, as soon as you shade then we can able to see the model has been converted into solid. Okay, and we have the texture option. This one we will not use now, it's not required. Okay, and if you don't want any of these things, that wireframe hidden or shade, then just click on none and you can able to see that just sketch kind of wing model. And if you want this in terms of ISO, okay, you can capture the image by fitting on screen, and you can take the image as per the required view, that is top view, front view, side view, ISO view, right ISO, left ISO. Okay, and also we have discussed about the X form. Okay, see in this general, as soon as we select the wing, okay, let me delete and let me do once again. As soon as we add our component, okay, wing component, see we can able to see that the new window. Okay, after adding our component, okay, wing component or any other component, or okay, as soon as we add, then new window will get open. That window, it indicates about the component, right? Whatever component you have selected, based on that component you will get one new window. Okay, so by using this window you can do any kind of alterations. Okay, that is the color. Okay, or your name. Okay, suppose you want to give this name as wing geometry of so and so aircraft, that is wing geometry of Cessna, or model of your Boeing 77, like that, whichever model you are designing. Okay, if you have those parameters, or if you have any one of your wings parameters, then just input your parameter and give your aircraft name or your model name. Okay, here we have wing model, so that's why your default name, that is wing geometry. Okay, color changes and color evolutions, whatever resolutions uh, you want to keep, that resolutions you can alter by using this option, that is the color change option. Okay, and similarly even I have told about the material. Okay, material, whether you want to add rubber based material or copper based or gold, silver, aluminum. Okay, so whichever material you want to add, you can add and just apply. Okay, here see the model what we have, that is just wireframe model. So this wireframe model we have to convert into solid shaded, then we can able to see the surface. Okay, that is the material which you have added. Okay, whether you have added aluminum or white rubber or your red default or glass dark or glass medium, which means in this general you can do color alteration and material change. Okay, whichever material you want, that material you can change, or you can uh, add to your respective component. Okay, and material density and other property whatever we have, that we have to import in this mass properties. Okay, and in the second option what we have, the x form, in the sense here I have told about the x location, whether you want to change your wing location or the model location with respect to the x direction or with respect to the x plane, then you can do alterations by using this option. Similarly you can do for your y location and z location. Okay, see here we have three axes, that is x, y, and z. Just I'll keep in iso view. Okay, so here we have three axes, x, y, and z. Okay, so if I do disturbance for this case, then we can able to see the model is getting disturbed with respect to that plane, that is x plane, okay, or x location. Here is our that direction, x direction. Similarly y and z. Okay, whatever you have seen here, similarly you can see here that the rotation for your model, okay, along x, y, and z. And if you want to change your origin, then you can change your origin. Scale ratio also you can change, you can reset, and you can accept, okay, and you can increase your span, okay, and projected span, chord, area, aspect ratio. Okay, now what I will do, I'll just delete this wing. I'll add once again just to show the parameter, that is the wing parameters, that is span. Okay, see, you can increase your span, and you can increase your chord length, okay, aerofoil chord length, or overall wing chord length, and even you can increase the area, or you can decrease your area of your wing. Root cap cluster, I told about you that, yes, about this parameter, root cap cluster. Root cap type, you can change from round to edge, or edge to flat, or flat to sharp. Similarly you can do for tip, okay, and incidents, leading edge clusters and trailing edge clusters. This is I have shown. Okay, you can increase your leading edge clusters and trailing edge clusters. So this is our leading edge, and this is our trailing edge. Okay, by using this leading edge cluster, you can increase your leading edge clusters, and similarly you can increase your trailing edge clusters. You are increasing your leading edge cluster and trailing edge cluster in the sense you are increasing the wireframes. Okay, yes, and in this section, now currently we have only completely one section. Okay, so like this you can split your sections, 1 2 3 4, like this. Just to split that, just you have to click on this option, okay, like this. Yeah, see here, now we have first section, second section, and the third section. Okay, so you can do your alterations with respect to the each and every sections. And in this case, you have told about the series of aerofoils. Okay, whether you want to go for fifth series or fourth series, or you if you want to keep your aerofoil wedge shape or biconvex shaped aerofoil. Okay, that also can be done by using the open VSP aerofoil menu. Okay, round, rectangle, aerofoil, pointed type. See, changes can be, yeah, see, in this case, wait, let me move to second section. Yes, yeah, See, whatever previously I've done, that was affected to the section 1. Similarly, like this, you can change to your second section and third section. Okay. And finally, blendings. And we have the modify delta angles and all, shift, rotate and scale. Okay, leading edge, flatted or rounded or edge sharp. Okay, like that changes you can do for your complete aerofoil. Similarly, now we'll go to our fuselage. Okay, because in this case what we have seen that fuselage, once we add the fuselage, then we'll get default fuselage. Okay, so for this default fuselage, you can convert this default fuselage into as per your required fuselage, as per your required parameter. Okay, which means once you know your fuselage parameters completely, by using that parameter you can design your own fuselage. Okay, just you have to add your length of your fuselage. Okay, and other parameters what we have. Okay, so if you know all these parameters, then easily we can design our fuselage. Okay, and similarly we can do other changes like material adapt, exform, sub design and all. Okay, so these are all things I have discussed so far in this 1 week of class. Okay, here one more thing you have to remember that I have told: as soon as you save the file, okay, it will ask you the path, right? So you have to choose any one path. I am on C drive. Okay, so instead of the C drive, you can change your drive like this. You can copy, yeah, like this. You can copy your drive and you can paste here. Yes, and do your model name and accept that. I will check. Yes, model has been saved successfully. Model 1 point VSP3. Okay, any file if you have with this name, that dot VSP3, that indicates that is our VSP model. Okay, the same model you can access anytime. Just go to file, open and access your model. Okay, so here we have our different wing components. Okay, so this complete part what we have, this complete part we will call the model hierarchy. Okay, so this model hierarchy, it will give you complete scenario about your all components whichever you have designed. Okay, so you can select this all components by using this select all option, or else you can just select individual component from this model hierarchy. Okay, and after counting your model, you can shade. Okay, just before shading you have to select the complete model and you have to use that option, shade option. Okay, yes, so you'll get default material. Okay, or the complete model that you can change. The select all, come to general. Okay, if you want to change the color, you can change the color. Okay, and you can add the material, whether you want to add aluminum or silver or blue rubber, red rubber and all. Okay, yes, so this is your model, and for this model we can view in these formats, that is front view, left ISO, right ISO, and you can capture image for your publications and all. Okay, because just to add image for our paper publications and for paper presentation and all, the image should be very clear and image should be very attractive. So like this you can capture your image by placing in a right format. Okay, and you can even change the complete model from solid into wireframe by just clicking on that option called as the wireframe option. Okay, like this. Now if you want to jump from wireframe into shaded or shaded into texture, then that is also can be done. Okay, just use your last option which is there in the surface, that is none option. Okay, fit on screen or have a look at your top view, right ISO view, front view, and other view what we have. Okay, so this is all about the Open VSP revision part, which I have discussed so far in this 1 week. Okay, so you should know all those things which I have discussed in the 1 week of our class. Okay, yes. Hello, sir.
Yes, sir.
Have you stopped the recording?
What, sir?
Recording, have you stopped, right? Hello.
Hello.
Yes, sir. Yes, sir. Recording is done.
Yeah. So you have ended the session.
Sir, just now I ended. Just now.
Okay, sir. Okay, fine. Okay, we can end the session.
Okay. Thank you, sir. Thank you.